Alpha emission. Objectives: to study how a smoke detector works, to know the reason behind emission of alpha particles, and to understand the basic properties of alpha particles. You would have seen a smoke detector. But have you ever wondered how it detects smoke? Inside the smoke detector, there is an ionization chamber. It consists of a small amount of radioactive element called americium-241, placed underneath negative and positive electrodes. These electrodes are connected externally with a battery and an alarm system. Americium radiates some kind of particles. These particles go on to ionize the air particles into positive ions and free electrons. The positive ions move towards negative electrode, while the free electrons move towards positive electrodes, constituting definite current in the circuit. During fire, the heavy smoke particles entering the chamber replace the air particles within it. As a result, density of air particles within the chamber decreases. Simultaneously, the rate of ionization of air particles decreases, due to which current in the circuit goes down. This drop in current is detected by the circuit and the alarm is turned on. Let us investigate what are these special kind of particles emitted from americium and the reason behind their emission. On plotting a graph of neutron number versus proton number for all the elements in periodic table, we can see that for lighter nuclei having atomic number up to 10, the number of neutrons is equal to the number of protons. This means the ratio n by z equals 1, and they are stable nuclei. But for heavier nuclei, this ratio is more than 1, as seen in the graph. These heavy nuclei are unstable. Do you know why? A heavy nucleus has large number of protons. Each proton in the nucleus exerts long-range Coulomb electrostatic repulsion to other protons. Meanwhile, the short-range and strong attractive nuclear force exists only among the adjacent nucleons. Thus, the mutual repulsion of protons existing throughout the entire nucleus is more than the nuclear force, in spite of the fact that the number of neutrons is more in the high Z region. The nucleus becomes unstable. To attain stability, the heavier nuclei with Z greater than or equal to 83 spontaneously transform themselves into lighter ones through the emission of one or more alpha particles. An alpha particle is a composite particle consisting of 2 protons and 2 neutrons tightly bound together. It is identical to the nucleus of a helium atom. Such a radioactive decay is called alpha decay. This identification was made by Rutherford and Royds in 1909, when an electric discharge was initiated in a tube containing pure radon gas. Initially, only characteristic radon lines appeared in the spectrum. After a few days, the radon lines started fading and new lines started appearing and growing brighter. These new lines were identified as helium spectrum. Hence, it was concluded that the radiation from radon gas was from helium nuclei. These helium nuclei were later named as alpha particles. The emission of alpha particles is efficiently used in instruments like smoke detectors. Summary: to attain stability, the nuclei with Z greater than or equal to 83 spontaneously transform themselves into lighter ones through emission of one or more alpha particles. An alpha particle is a composite particle consisting of 2 protons and 2 neutrons tightly bound together. It is identical to the nucleus of helium atom. An emission of alpha particle is efficiently used in instruments like smoke detectors.